Hello, everyone, and thank you for listening to the Fabrication Friday podcast. I'm your host, Joe Fairley, certified prosthetist, 3D printing enthusiast, and owner of Ascent Fabrication. Fabrication Friday is an all-around fun time where I talk about 3D printing applications, conduct interviews with industry leaders, and much more. Come join us every Friday for an informational discussion around the evolution of the additive manufacturing field and how we utilize various digital workflows and 3D printing methods in our daily work at Ascent Fabrication. Hello, everyone, and welcome back to the Fabrication Friday podcast. I'm Joe Fairley, your host. Today, we're starting out with our print of the week. Our print of the week this week is a floating shelf. This floating shelf has been a really cool project to work on. You know, we just kind of get some neat ideas sometimes here at Ascent Fabrication, and we just run with it. Getting into all things 3D printing. We're looking to print some cool stuff that is more consumer-based and people are going to want in their everyday life. So I was looking to print some household items for myself, and this floating shelf idea came to mind. It's in two different pieces. We have the both printed in different PLAs. Could be really any PLA, different colors. Would be pretty neat to kind of get into, maybe some different materials with this design as well. Maybe even a wood fill solution there would be pretty interesting. So we have the wall anchor as the first part. That was 214 grams and printed in 5 hours and 29 minutes with a 1 millimeter nozzle. It has 3 holes for anchor points to go into a wall. With a set of 3 screws, and this could end up being a consumer level product that could be on our website at some point in kind of a marketplace feature where you could order this as a kit. You could order them in different sizes, so that could be really interesting, different colors, different sizes. The actual floating shelf itself is also printed out of PLA, like I mentioned, and is printed in 5 hours and 21 minutes, 738 grams, with a 2.5 millimeter nozzle on the Filament Innovations Kratos. So the Kratos there is really, really good at printing big and fast. We like using their 2.5 millimeter nozzle and printing in vase mode. This floating shelf is printed in vase mode. The wall anchor is not. So that is our print of the week, fun, kind of cool project to work on. And so today, to my left here from LutraCAD, I have Niels. Niels is has a wonderful vision for the foot orthotics software and the actual production status that this can get to in the field of foot orthotics. So very happy to have Niels on the podcast today and chat about his entry point into 3D printing and kind of where LutraCAD is heading. So Niels, thanks for coming on.
Thanks, Joe, for having me. So I'm Niels, and we have been in foot orthotics for like 12 years. And we've been printing since 2016. So mainly SLS and FDM. And now we got into the field of MJF TPU printing with lattice structures. So not only working on FDM printers, but we're working with the goal to produce any insole on any kind of production method. So we now focused on making insole software, shoe loss software, and midsoles. And most of the time, people are making them by hand or are milling them. And since the last few years, we've seen the conversion to 3D printing. And so that's where we really focus on. And we try to, there's a lot of different printers on the market, and everyone has their expertise. And our expertise is really software and workflow optimization. And we try to take advantage of the knowledge of other people for scanners and printers and materials. So as you can see in the background, I'm having a Race 3D printing some polypropylene insoles. So we print any insole, and this is just a printer from one of the printers we like. So we really try to focus on a set of printers, and if everyone has a different printer, then we can probably work with that printer as well. So from design software into printing, we try to make it one click on a button.
Yeah, so what do you think actually makes a good 3D printer for foot orthotics specifically? What would be your list of attributes where, if someone is looking to try to start to get into printing foot orthotics specifically, or if they already have one, what should they be looking for in a printer?
Well, in my opinion is that a lot of printers don't have the big enough build volume. So or you have to rotate the insoles, or it doesn't fit. So for TPU, we really like direct extrusion because otherwise you're gonna have a lot of issues. And for TPU, we like to build on or print on glass. But you can always buy a glass plate and put it on top because otherwise you have to put a lot of strength into getting that print of the build plate.
Mhm.
So if you're gonna print it like me, just next to your desktop, I would suggest getting a closed printer with a HEPA filter or something like that because otherwise the fine dust, or how is it called
Sure.
in English, something
Yeah.
like that, will be everywhere, and it's probably not that great for your lungs. So that's why we like to print closed, or you have to get great um, air circulation within the chamber.
Sure.
So mainly looking at build volume, the kind of extruder type, your build plate, um, and well, uh, if it's safe to print within your working area.
Sure, sure. Yeah, so I mean, with some of those materials that you were talking about, polypropylene, TPU specifically, I know in the past we've talked about Color Fab's VarioShore. We
Yeah.
prep with VarioShore all the time, started to do some foot orthotics with it as well. What do you think in terms of the applications, maybe specifically for the diabetic population? Have you looked into anything specifically for that where right now foot orthotics are kind of this tri-laminar multi-material, multi-density foam? Do you think VarioShore has a place there? And what have you heard from other customers?
Yeah, so we for VarioShore, we already have a lot of customers using VarioShore also for the diabetic market, because it can be soft in specific regions. And but if you make it too thin, you might want to have a thicker top layer to uh, well have a thicker and softer insole. Because if you print the materials, you sometimes don't have any way of adding multi-density in mostly on the front. It's really hard to
Right.
create the density because you don't have that many layers to actually apply that.
Hmm.
But we all for VarioShore, we already have a lot of customers printing it for the diabetic market, and it seems to be working really great.
Yeah, no, that's great to
Uh,
hear.
but for
Yeah,
I don't know if I haven't had any feedback about normal TPU, so I can't really answer on that. But VarioShore
yeah,
seems to be working great.
yeah. I mean, so if we can get something that's a little bit more soft feeling, and obviously with the durometer coming from the different densities of infill and different infill patterns we can have, right? That's definitely
And
a step in the right direction, pun intended there for foot orthotics, for
yeah,
the diabetic population. I know people are a little bit hesitant to take that on only because we are just using one material, and especially here in the US, because there are specific codes that represent a device, people will be sometimes shying away from certain materials like this, especially because they're newer, simply because they haven't seen those results yet. So that's very nice to hear that you're seeing that elsewhere. For our listeners too, can you just kind of introduce, where you're from and what the whole suite of LutraCAD looks like?
yeah, yeah, certainly. But first, about VarioShore, one small thing is that um, we can have different densities, we can have different infill patterns, but for Vario specific, changing the temperature will change the shore value. So, but so far we haven't seen any slicer that can change the temperature per layer or per section,
Hmm.
because then you can really apply changing the temperature from, I think, well, it has a really wide range of shore value only by changing the temperature. So, getting back into Lutracat, where we're from the Netherlands, near Eindhoven. And we started with the insoles, and then we've been expanding our product range, and we still have a lot of customers doing the production by milling because milling is faster, but it has a lot of waste. So if you have like a big table of 20 pairs of insoles, then you can mill that pretty fast. But if you're going to be printing them, then it would probably take more than 24 hours to get that ready. So it's, in that fact, it's, if people have large production, it's sometimes hard to convert them, but they have to know that a milling table is also pretty expensive, and
Yeah.
3D printers are probably a lot cheaper than the milling machines, and also the material. And because you've got a lot of waste and you need to have a lot of air circulation as well, and you have to, well, it's a dusty place. And with 3D printers, it's really clean. You don't have any, barely have any waste.
Yeah.
So all the materials are used really efficient. And that's what I like about 3D printing. So if we're gonna look at environmental, then 3D printing is already like 10 times better than milling if you look at the environment, because all the waste we got.
Sure.
And where I hope that the future of 3D printing is going is that we got more biodegradable materials. So we now they're getting deep biodegradable TPUs, or even EVA. But one of the things that concern me, and I am really want to experience it, if what if you put biodegradable materials into your shoes?
Hmm.
How long will it take before it degrades and the
Sure.
material, the insole quality reduces? So there's a lot of podiatrists that are also afraid of, for example, for EVA, after 1 or 2 years, your EVA needs to be replaced
Yeah.
because it lost its functionality. Your feet change every year. Um, and so far, the 3D printed products, they last too long.
Yeah.
And maybe, and maybe with the biodegradable functionality, you can get your customers back in stores like every year or every other year. So it might be,
Interesting part to tack on there too. Yeah, if they're working too well, and we've
yeah,
seen that with some of our prosthetic devices too. That the VarioShore we also use for the flexible inner sockets in
yeah,
prosthetics, and yeah, we've had people wearing them now for over a year and a half. And one thing that we see with the flexible inner sockets traditionally with those materials is that it'll have this cold flow and creep of the material. The material at the ends will kind of expand out a little bit and thin out, as well as discolor and everything else. But the VarioShore doesn't do that. And the cushioning that we build into the bony anatomy, the infill patterns,
yeah.
that doesn't pack out either, the same way traditional foam does. So that's an interesting point to bring up.
So you don't want to lose too many customers because of 3D printing, and so we've been thinking about a couple of ways to solve that issue, to add an expiration date or print an expiration date on the product, and just say, okay, well, if food's past their expiration date, a lot of people don't even eat it anymore while it's still good. So if you do that the same with insoles or other orthopedic products, you might let your customers come back, or just advise them, well, your feet change, the product needs to change, and if you wait too long, you might experience other issues which we could have resolved well beforehand if you came back to our clinic. So
Mhm.
so that's one of the things people are running into. So it's pretty new, 3D printing in the market, but in the last 2 years there's a big shift. I think like 90% of the customers who currently reach out to us, they want to start 3D printing,
Hmm.
and 10% is still they want to get new software for their milling machines.
Yeah.
Uh, so the thing we did is so we can make the G code for all the milling machines. So we really optimize that for insole milling. So we can print faster without the reduction of quality. And we are now doing the same for 3D printing. So for example, the Vario Shore, there's a lot of research needed to print the right quality with the right speed.
Hmm.
And a lot of people don't have the time to do that research. So we're doing that research instead, and then we say, okay, this printer with this material will work seamlessly, and we can just say send to the printer, and the printer will start running. So,
Right.
for example, for the polypropylene, you get a lot of vibration if you print vertically, and within our software, we found a solution to prevent that. So we can print polypropylene insoles horizontally and vertically, and uh, this will make the change faster from changing from a traditional or more traditional production method into 3D printing. And
Right.
this way we try to push everyone to more modern, well, production methods.
Yeah, that's something that I really like about the software. I've been testing it out now over the past week and have printed out a couple pairs of insoles from it for my wife actually, and testing out some
Yeah,
biomaterials from Exteller. One of their bio EVA, and then there was another polyolefin from recycled bottle caps that we're trying out as well.
okay.
Some interesting materials there on the bio side of things, but being able to have those G codes and the slicer settings already built into the back half of your design, I think is extremely useful right now, right? The only other company that I know of currently doing that, going from straight from design and having slicing in the background, is a company that's actually right down the street from me here in upstate New York, called PVA Med. That's actually nope, not that printer. This over here.
Okay.
This one opposite the camera. This printer, the Emergence Pro, was one of their latest printers. I think they've got one more new one out right now. Very big build volume, specific to the prosthetics market, as they were looking into mostly test sockets that they were printing in PETG. Obviously, it can be used a lot for a lot more things, and we've really pushed it to the limit. But their software, Rapid Plaster, has the design capabilities to do those clinical modifications, very similar to LutraCAD. And then, but again, only for the prosthetic side of things right now. And some of their design is a little bit pretty limited in how they spit out G codes. So, you don't have really any say in how that G code is coming out, and it's only very specific to what they've built. But it is nice to see that for different materials, different devices now, different softwares like LutraCAD here are having, that seamless solution of, people can even have templates of, certain designs for insoles. And it was fairly quick to go through that design and get to that G code stage.
Yeah, so yeah, that's why what we've been focusing on, and we have like a step-by-step process. So in every step, you exactly know what to do, and in the end, you will be at the production stage. So you start with importing your scans, selecting a template, adding your elements, and then you do your modifications, and then you get into the 3D printing settings, like if you want to add text, if you want to for polypropylene, if you want to add holes, or if you, well,
Mhm.
anything you want to do with 3D printing. And in the last step, you add it to production. Uh, and within your library, you're free to modify any template, any insole, or element, however you want. And if you're doing a lot of the same kind of insoles, you can even make macros. So you record your session, or you build up your template and you just run it, and the insole will be generated. So from for big production facilities, we optimized it even more because we can have an iPad app where you scan the food. you enter a specification form, and our software can read that specification form and apply all the settings that have been selected. So the only thing you need to do is like send to printer. So we're thinking about what do people need to do by hand, or where do the mistakes happen? Because if you have to re-enter a prescription form, mistakes might change. A 1.5 might be a 2.5, and then you create a device that is not following the specification.
Right.
So from A to Z, we try to, like, within 2 minutes you're ready. So we really try to get people back to the clients and stay out of the production.
Yeah, yeah.
And
I like how seamless it is and being able to allow more people who aren't as familiar with 3D printing, utilize your software and then either, send it to their own printer or maybe possibly, send it to another production facility, right?
yeah, yeah. So yeah, you can select if you want to do the production yourself, or you can say, okay, I want to outsource this at, well, Essence Fab, for example, and then they will you will get the message that you got a new order. And even when the so within your software, you define because you got some 3D printing settings, like if you want to have the top closed or open with the bottom, and the infill percentages and all those settings and everything will be sent to the production facility.
Mhm.
So you still decide on how your device is produced
Okay.
with your settings, but the production facility just needs to run the G code.
Right, right. So with your ability to um, go through the actual carving or milling,
Yeah.
uh, do you see that you have some customers who are actually starting to adopt 3D printing that are milling them right now? Or, what are some reasons why they might want to? I know you talked about the reduction in waste, the other kind of environmental things of
Yeah.
having the dust and everything, but have you been able to convert any of those customers?
Yeah, but it's slow. Well, it takes a lot of time to convert those people or customers. We now have, for example, someone's doing like 500 polyprop per week and 200 to 300 EVA installs
Hmm.
with milling, and they now want to start to change into 3D printing, but they will do it like step by step because they first need to introduce it to a few customers. They need to be satisfied with the end product,
Mhm.
and because it's not EVA anymore, it will be a TPU, and then they have to acknowledge and, well, test it. So we tested it a lot with a lot of podiatrists and orthopedics, but they have to redo the same process. So if people really don't want to go into 3D printing because they think it's too new or they're scared, then they will not convert those customers to 3D printing.
Hmm.
Uh, but we see, so the process, it's really slow. So we send a lot of samples around the world to like, okay, uh, we have people that tested with TPUs and they say, okay, we haven't found the right material for our customers.
Yeah,
And then we have a chat with them. Okay, which brands did you use? What did you try? Which printer do you have? And then we ship them some samples of different materials that we have a lot of positive experience with.
sure.
And then such production facilities are already thinking about, okay, how do I get this to my customers? And just by, for example, VarioSure is one of, well, it's one of the materials people really think it's more like a fabric instead of a plastic.
Sure.
And 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 well, they then they start to, well, see the light and see, okay, this is gonna be a possibility to change into 3D printing. So
Mhm.
we have customers that do like 200, 300 pair of insoles a week and now starting to 3D printing. And we have to find a way to maintain the printing speed because 200 to 300
Sure.
pairs a week, you need a big printing farm to be able to manage that.
Yeah. Yeah, no,
But
that's coming along though. You see more print farms coming along and people are, increasing their capabilities of printing. Like we've been talking about the black belt,
yeah,
belt printing, I think really has a space for that. We've talked about, Poto printer as well. But yeah, so with that kind of, production level status, obviously LutraCAD can handle that, and from
Yep.
a software standpoint, so that's pretty cool to see.
Yeah. So such production facilities with those quantities, they well, a race is really nice, but standing next to your printer every 2 hours and don't well, you can only print like when people are on the job. And with printers like Black Belt and Proto Printer, they can print 24/7. So you just have to replace the spool once in a while,
Mm.
and it can print overnight. It can print during the weekend, and I think it can print 72 hours without any interruption or any people that needs to do anything. So
Right.
uh, it's just putting a big basket at the end of your printer, and when you're back in the next morning, try to, well, you need to add text because otherwise you don't know which install is for which
Yeah.
customer. And that's also, so we can put them in a basket. So then the next small tricks that we need to apply is that if you have the install, that we just make a small string to the next one, and then you have already pairs connected. So you don't have, if you have 50 pairs in the basket, you don't have to find the other
Yeah.
install in the basket, and we can just connect it with a small line and a small modification in the G code. So there's a lot of small tricks that can
That's a great hack. I love that. That's awesome. Yeah.
it's a small trick to uh well to be more well it's
More
how to say
efficient
it
with it. Yeah.
more more efficient, but it's so we're like really software provider, but we're really optimizing the production technique itself
Right.
to be more efficient in your production workflow.
Right. Right. Have you seen Mosaic Manufacturing, Mitch Deborah and their array?
Yeah, I've seen it on the on I think 2 trade shows.
Yeah.
And it's really nice that they can just get a plate of it, stacks it in the printed storage,
Yeah.
put a new plate in, and you can continue production with uh, non-belt printing.
Right.
Uh, and they can even have multi-materials. So you can print multi-materials as far as I've seen within
Yeah, to some capacity. Yeah, with
Yep.
their palette, um, having that ability to feed in different materials at one time.
Yeah, and depending on how much storage you need, you have room left for as many printers as you can stack, and how the less build height you need, the more printers you can stack, and the more spools you can add. So that the so if you have like 6 printers inside, then you can also print overnight. So that's also a good
Sure.
solution. And on a trade show, I've seen it was a really big print forum. So they had Delta printers.
Yeah.
So they have, how do you call it? A belt that's running. So you print on a plate, then that plate's running on a conveyor belt, and that
Uh-huh.
runs out. And then the next build plate comes up, and it's once the print is ready, it rolls it on the conveyor belt, and you can keep printing as well. And at the end of the conveyor belt, they also build a system where they had a big racket where it would just roll
Yeah.
into, and then you can also do production. So there's a lot of people thinking about really going into, well, continuous production. We've
Yeah.
even seen that they have this kind of printers, and then the side door opens, the build plate rolls out on a conveyor belt, and then the next build plate rolls on the.
Yeah.
Uh, so but we need that kind of machines and printers
Right.
to convince big production facilities that they don't need the manpower to stand at the printer every 2 hours, because
Right.
that's no way of working.
Right. Yeah, you can probably only have, one person operating maybe 4 or 6 of those machines at one time, potentially, and then but what of those people that are printing out 300 pairs a week, right? That's
Yeah,
that's on another level that they would need, you know, a close to almost 100 printers anyways,
yeah,
trying to get to that status. That's really interesting to hear about the conveyor belt going around, because I know there are instances in the again in the prosthetics industry and orthotics where um, there's a system that has the carver and will carve out of the block of foam, and there's a conveyor belt, and it just goes into a room once it's done. And the person takes it off of the plate once it's done, and that clear plate goes back around with another new block of foam for it to carve. I
Yeah.
don't see why it couldn't be like that as well. You have one giant printing room where you have all these different build plates going around. I think that's a great idea.
Yes, yeah, and as we see over here, we have the Forum Next trade show where a lot of people show their printers, their materials, new pro production techniques, and we try to go there every year and be amazed about what people think of. Even machines with 16 different colors and
Yeah,
a lot of a lot of cool new features coming to market about 3D printing. Also, a lot of things that aren't even possible with normal manufacturing to
right,
like if they need to be connected like a ring, you can print that, but you can't produce that without any seams otherwise.
right, right.
So,
Yeah, that's
so
that's the other big benefit of that, right? Being able to 3D print something in a way that can't otherwise be manufactured is definitely useful. I wanted to ask about you mentioned the shoe lasts and then those other positive shapes too. So what do you see the purpose for there? What materials are you printing those out of? What are those customers looking to get out of that?
so for shoe last, it's a little bit hard to it takes a lot of time to print those. And also people still need to be able to add nails into it to uh, stretch the material and actually make the shoes.
Mm,
So to print that, we have customers in the UK that just print with PLA, but then you need like 5 or 6 outer walls to be strong enough to that you don't break it. And you need a lot of times you need to print it in parts because otherwise you can't get the shoe lost out of the shoe anymore.
mm,
So we need to make 2 or 3 parts and then you can connect those again in order to make one shoe lost.
right.
So a lot of times people make test shoes in the at least in the Netherlands. So they make test shoes so people can fit the shoes that will be made or the shoe lost. So they now mill the shoe lost, then make vacuum plastic around it, and then you can test it and you can see where the pressure is. And to skip the step of production or milling, uh, we are now printing this like a test shoe. So within our software, we can make an offset and we can slice this and you can still cut it. It's not sharp or anything. So this is polypropylene.
Sure.
Um, and now we got feedback from our material supplier if that PET might be more transparent,
Yeah.
but it might, and I think it's hard, it's more sturdy.
Right. Yeah, it's pretty
Uh,
stiff plastic. We use it all the time for our test sockets and in prosthetics. Yeah.
yeah, yeah, but this is printed with a single wall in phase mode, and I don't know if the adhesion of the layers would be enough or if that would break, because that's a real benefit of polyprop, that it has really great layer adhesion. And I haven't tested with PET yet. And there's we currently are testing it, and we haven't announced it anywhere yet that we're working on it
Sure.
because we're still having some overhang issues,
Sure.
and
Sure.
we're trying to solve that with lower layer height, um,
Mm,
lower print speed, and bigger nozzles.
yeah.
So within the next 2 weeks, we hope to have a good printed test shoe,
Nice.
and then people can fit the test shoe. It's transparent enough, and then if they're gonna produce the shoe last, they don't have to stick more material in it or use our grinding machine to get rid of material, and they
Right.
can produce the shoe last directly as a good end product. as a product they could use instead of having
Right.
to make adjustments afterwards.
Would it have to be flexible like that? Because the PETG that we use specifically is very stiff. So yes, you could cut it down the anterior there, the front,
Yeah,
um,
so we
but it
yeah, so
wouldn't
that
be
this
able to open like that one.
yeah, so this you need to be able to put your foot inside.
Yeah, yeah. So I don't know if if PETG would really work out if it's that stiff. Although if you could just make a slot in it big enough to where they could fit their foot inside, but not completely, open the whole thing up, that could be an alternative. Or
Yeah,
I don't know if you could have just split it down the middle and you could fit the two halves together, maybe.
yeah,
That could be
sometimes people need to do a short walk on it to see how it fits.
yeah,
And if you have to walk on it, then you have to, well, I don't know how you do to
sure,
glue it back together. So that I don't know if that's I put so this is kind of so next to the software we make, we do a lot of product development, like how can we make this work in the market? Because haven't seen anyone else print these things.
right,
And we think there's a market for it if you do, because now you can print this in-house and milling shoe loss, as most of the time is outsourced. So it takes a lot of time before getting the actual lost in the clinic. And then so that will probably take around 10 to 15 work days. And if they can print this in overnight, a
yeah.
pair, then the next day they can already help the customer and then order the shoe lost or even print it.
Interesting. Yeah, I don't really know anything about the shoe industry. So I don't know who would be doing something like that similarly here in the US, but I wonder if that's kind of different from what's going on in Europe
No,
for shoes specifically. But
no,
uh,
we have customers in the US as well that make
yeah,
boots.
okay.
And they use our software to make boots, high boots.
Cool. Okay,
So it can be applied to anything. It's just
sure.
well,
Just figuring
there's
out that workflow for it, right? Yeah,
yeah, and and for this example, it will take some time before we can actually make it work correctly because well, there's some minor challenges we're currently having. And once we've solved that, then we can speed up the delivery time of shoes, custom-made shoes or boots that are being delivered to customers. But not everyone is making the test shoes. Sometimes they just make the shoe last, make the shoes, and then it's good. So that also depends on the region or the country, because in the Netherlands they well sometimes really overthink the product and they want to make it really, really, really specific. While if it was a little bit less accurate,
sure.
it would also be good.
Right.
So that's why they use these test shoes.
Yeah, managing the expectations of some people where their ideas are going all over the place, but then in reality, when you're trying to print something like this, we might have to make some sacrifices in some of the design or just the techniques of printing might have to get a little bit more intricate.
Yeah.
You might sacrifice a few more hours of print time for, or maybe a couple extra dollars of material or something, in order to give everyone exactly what they're looking for, right?
Yeah, because if you now outsource and it takes like 10 or 15 days before you actually get your product,
Yeah,
and overnight you can print this because this took like 3 hours, I think 3.5 hours, and I think it's 5 or 6 euros on material. And if you outsource it and they ship it to you and you need to make big modifications and you need, well, I would be happy if people don't need to use the grinding machine anymore. And I think a lot of people are happy to not need to use that as well. So I think it really adds value and benefits the whole production process of custom made shoes.
absolutely. So, we've been talking about primarily FDM 3D printing.
Yep.
Where do you think, SLS and MJF fit in this equation? Because if we're talking about dollars and cents, it's going to be much more expensive to get them printed, by that form. So where do you think that fits in with all this?
So there's different quality and different expectations. So we have people that use FDM because it's more affordable than SLS or MJF. And if we now work together with BHSF to create like more of a lattice structures, but this production is between 40 and 60 euros per insole
Yeah,
because it's printed on MGF printer, and those printers are expensive. The materials are expensive, but it depends also if you're in or if it needs to be paid by insurance or if it's paid by a private.
sure,
Because if it's private, it doesn't matter if the install production costs 100 euros, because then people go for their own health and the own quality. And if it's insurance, it needs to be the cheapest of the
sure.
way of production. So
Yeah, that's a good point.
um, yeah, and we for harder installs we see people using uh, SLS. So next to milling the polypropylene, we see a lot of people going into printing with SLS, be it pH 11 or pH 12, because then you get the same kind of product. And with FDM printing, uh, I think it's polypropylene hasn't been around for too long, and people are kind of waiting or think it's new, and they see a lot of companies. If you go to trade shows, they print SLS insoles, 3/4 insoles.
Hmm.
Uh, so they see the product and they know what they will get out of it if they buy such machines.
Right,
And now in the last year, I think we try to promote the FDM polypropylene more and more. So also there you're gonna see a small shift, because if you're gonna outsource SLS pH 11 or pH 12, it's between 20 and 25 euros per pair of insoles.
yeah,
While if you're gonna look at the costs, then I think polypropylene printed insoles, like I have here in the back, I think it's 8 euros of material. So if you
right,
and you don't have to do any extra work, and it saves people like 12 euros in production.
yeah,
The only thing they need to do is buy the material and start printing.
right,
So so with different printing techniques, if it's in consumer market like private, then or in stores, for example, more comfort insoles, people are willing to pay more money for that. And if it's for the insurance, then it needs to be really cheap.
right. Yeah, no, that definitely makes sense. I had a person come into my shop here yesterday, and just so happened to have one foot orthosis on one side, due to a leg length discrepancy, and he had two of the same foot orthosis, but then he got rid of a pair of shoes, I think he said, and one of those orthoses went with it, and he just forgot about it in the shoe. So he asked me if I could, print him out a foot orthosis. So, because he already had one, we went through just 3D scanning
Yeah.
the foot orthosis itself, and we're able to produce it for under $5 in material costs with polypropylene. The amount of time it took me to just clean up the scan. I used
Yeah.
the comb scanning app on my iPhone. It took me 5 minutes to clean it up in Autodesk Mesh Mixer, and we have it, printing out in a couple hours here. To have it ready for him, at a much lower cost than his traditional insurance. So I think that side of things is quite interesting when we talk about how people are thinking about getting these devices paid for. Um, because it's very different across the world for what people are comfortable with,
Yeah.
whether they're paying out of pocket cash for something, or they're going through their insurance, and what's available to them or what those clinicians offer as a option to
Yeah.
them, right? That varies so widely over the span of the world right now. So I think that's interesting to note that even if we had the more expensive MJF SLS it's still not incredibly expensive to the point where if they paid out of pocket directly for it, they'd be getting a still a pretty very high quality product at a somewhat reasonable price. But compare that directly to FDM, and it's still 2 to 3 times the amount, if not more.
Yeah, and it's yeah, so it's totally about consumer market or medical, and there's a big change shift in between in what people expect and what they could afford, or what they're, well, for example, in some countries insurance only covers a maximum of 60 euros, for example. So
Hmm.
the intake and the how do you say it, the uh, to see a customer, diagnose them,
Yeah,
do the production, deliver them, and after a few weeks they come back and you have to see if everything's okay. That all needs to be done within 60 euros.
yeah,
But if you look at different countries, over here in the Netherlands, I think it's between 240 and 300 euros. If you look at the UK, it's 600 euros only for seeing what needs to be modified on the installs, and then you haven't got any installs yet.
right,
So there's a really wide range of what an install may cost. And if you look at the countries where insurance says it needs to be within 60 euros, then MJF is not the solution,
right,
because
right.
only the production cost is already too high.
Yeah,
So it's, well, being, yeah, so it's really depending on, because if you go into consumer market and it's more of a comfort install. So if I go to a store, I buy expensive shoes, then my installs, it doesn't matter if your installs are 150 or 250 euros, because if I got shoes for 600 euros
yeah, yeah,
and I want to walk really great, then the installs, if you say, well, they're custom made, we scan your foot, you do the whole experience,
yeah.
then it's not a problem if they're 150 or 250 euros.
Right, right. Yeah, it's all in the relative, retrospective things and how people
Yep.
perceive what they're getting out of it too, right?
Yeah, exactly.
That's that's interesting to hear. Well, I appreciate you going over the software a little bit with us. I look forward to diving into that a little bit deeper and seeing all those different integrations you have. Being able to go from 3D scan directly to G code, I think is an awesome step forward
Yeah,
in bringing this, to be a lot more user friendly for these people using the software. And obviously, you're doing a lot of product development and everything in the
yeah,
background, so that's great to see.
yeah. And so for the complete from scan to G code, I think that's more non-medical, because because we can do that for, if you're in a shoe store and you're at a column or a kiosk, scan the foot, and before they pay, if they pay, then the printer will start. That's one of the solutions we have. But most of the time in the medical sector, you need a specialist to confirm everything is on the right spot. And because it's a medical device, someone has to deliver it and it needs to be checked. So
Right,
we can automate the process, but before sending it into production, someone needs to verify that it's a correct device.
right, right. Yeah, no, having that level of clinical insight is still very, very, necessary in that step. So I know you and I have started out our conversation before the podcast here and
Yeah,
talking about some ideas around how we can integrate better with these health professionals around the world to maybe have some of that oversight into how these devices are being delivered and connects different people across the world with designers and health professionals and people who are printing and getting that
yeah,
to the consumer. So it's an interesting pathway that I think is developing here, and definitely excited to be a part of it with you guys.
yeah. So yeah, it sounds really great and really about, well, building a community and using the expertise of everyone, and like, well, building one big factory for install production or printing anything that you would like.
Absolutely. So is there anything else about the software that you'd like the listeners to hear about, or how can they get in touch with you? And they'll be able to get in touch with me, obviously, but otherwise, what should they hear about?
Yeah, or contact Joe and he will do an introduction, or we schedule a session together, or reach out to us at, my email is niels@lutracat.com, or follow us on social media. And we really try to help people with the right product, the right solution, and the right workflow. And I think that's where our strength lies, and to simplify the process for our customers. So if we need to make manual changes to optimize someone's workflow, we can do that. We build everything in house.
Hmm.
And if people want to go more in consumer market and they see with a kiosk, if they have, I don't know if the big brand of they we had big brands contacting us about making installs for their employees, so we can connect the right people and the right orthopedics or podiatrists to also supply those kind of uh, projects.
Yeah, I think the possibilities are endless there, and I think you
Yeah,
guys are in definitely a step in the right direction. So, um,
yeah. If people talk to us, I'm sure we can get them enthusiastic about 3D printing and working together.
absolutely. Well, yeah, thanks again, Niels, for your time, and looking forward to hopefully seeing you at Form Next, maybe next year.
Yep.
Um, thank you everyone for listening to today's Fabrication Friday podcast. And so now getting into our tech tip of the week. Our tech tip of the week this week is drying out your filament. So everyone knows that there is a little bit of hygroscopic nature to a lot of these 3D printing materials. Hygroscopic meaning some of these materials will absorb moisture from the air. This can kind of happen within a pretty quick amount of time, actually, within just about 24 hours. If you're over 40% humidity, then you really should be drying out your filament. During the winter for us in upstate New York, it's not that big of an issue because our humidity levels are under 30%. So, don't really have to worry about that so much in the winter, but we primarily keep a lot of our filament in closed storage bins with other types of rechargeable desiccant packages. Actually, very useful. Get them from Amazon fairly cheap, and you plug them into the wall, and they dry out the pellets, and they keep your filament, and then that's in a storage container, pretty well dried. The other way that you can do some filament drying is with the Print Dry Pro. Print Dry Pro has come out with their new third version. We do have this on our website for sale. We are an official reseller for Print Dry. So $245 there for the large spool system. It will go up to 3.5 kilograms for one spool in this large spool kit. Otherwise, we can add on one more set to do up to 4 or even 6 1,000 gram spools or under. So once you get up above, the 6 range of those different stacks, then it's not as effective toward the top, really, of drying out your filament. So we're not going to be stacking a lot of those on each other, but you could very easily dry out 2 1,000 gram spools, or 4 or even 6. So dry out your filament if you're over 40% humidity. Some things to look for if you suspect your filament is wet, would be an absorbent amount of stringing in your part. If there's a lot of strings, it could also be due to some of your retraction settings. However, a lot of moisture could be getting into that part, and some oozing and inconsistent extrusion can occur. So keep the filament dry. PLA, PETG, TPUs, you really have to keep dry. Polypropylene, however, or our new carbon fiber polypropylene, does not need to be dried. So that's a pretty nice feature of some of those filaments, and they're very robust materials as well. So dry your filament, folks. It's hot. It's summertime. Thanks again for listening to the Fabrication Friday podcast. We'll see you next week.